welcome to the last session, but not least. Andrei will present some very interesting topic. You know, like nowadays we very often listen like Kubernetes from every, from every people, and Andrei has has another opinion about this, yeah, and maybe, who knows, maybe it's a future of our Kubernetes, maybe future of all of our clouds, yeah, who knows, but for me it seems like maybe new iteration, new circle, evolution of our IT area. I mean, what the technology will be not today, but will be tomorrow. So without further ado, pass to you, Andrei. Please share your screen presentation and go ahead.
Thanks, Vitya. Wonder if it works. Do you see my screen?
Yeah, I can see.
Okay.
I believe other people can see.
Great. So hi guys, let's start, I guess. And here I am. I'm Andrei. I'm a systems architect, and I'm working for EPAM, and I've been in the industry for over 17 years. So the course of my career, I used to be a DBA, a network engineer. I supported big Windows-based platforms, taught people to use Windows platforms, and then at some point I decided to switch to Azure Cloud. And now I'm playing the role of systems architect, helping customers to organize their delivery workflows and build cloud platforms. So the topic for today is an open application model. My aim is to tell you, what open application model is, why to use it, and what are the benefits that it brings. In order to understand this, we need to start first with a few examples of organizational structures and see how they affect the process of delivering business value through software products. Then we want to look at one of these models, which is the most common one, in my opinion, in more detail. And then we want to see why this model, I would say, why this model is so common, and why that kind of approach will never go away, fortunately or unfortunately. And then we want to look at the open application model itself to see how it can help with solving all of these various problems with this common model, with the common organizational model, because everything that we do in terms of deployments and automation, and this the work that we organize is basically based on the organizational structures. That's why we are talking about them in the first place. At the end, I want to briefly describe or show the approach that we took in terms of implementing this OEM model for our organization. And if time permits, I would like to give you a short demo on how it looks like. So first of all, let's start with a few examples of organization models. The model you see on the slide is familiar to many, or you will see in a second, is familiar to many people. It's perhaps the most common, most sold out model. Organizationally, we can say that there are two major roles involved in making software and delivering business value through the software. It's basically developers and developers organization and operations organization. In big companies, these roles are played by different people most of the time, especially in big companies. And different organizations take part of it, or even different organizational structures of each company take part in this process. And in this model, and in this particular case, we can see the big overlap between these organizations. So typically in big companies, there are multiple organizations, working on delivering or on producing and delivering their software. So in most cases, we would like to have a big overlap between these organizations in terms of their roles and responsibilities. This helps to share these responsibilities, to share tasks. And another point to this picture is that, as you can see on the diagram, for this particular case, for this particular approach, the size and the size and capacity of the dev organization most of the time is slightly bigger, or sometimes even the same as the size and capacity of ops organization. In rare cases, or within the relatively small organizations, even the same people play both of these roles in different times. However, this model, for this model to work, what we typically have is a web-based or web-oriented product, which may be built of relatively small amount of parts and supported or created by relatively small amount of teams. I would say up to 10 teams, maybe 9 teams. These teams are small enough, highly professional, and team members can wear multiple hats depending on the context. All of this makes this model flexible, but on the other hand, it's pretty limited to the products that are being created. And because these products are directed to the cloud, they're built for the cloud and architected based on the cloud technologies in mind. So this particular organization model works, but its scope is pretty limited to modern applications that are being built, right now. The more common situation is when technology business unit of a company consists of smaller organizations or groups. And typically, the dev organization is much bigger than ops organization. In this case, this DevOps role is played by dev organizations in lower environments and ops organizations in production. This model is typical for products that are, and for more mature organizations that are on the market, for a long time. So this model is typical for products that are relatively old and undergo their major upgrades, being migrated to the cloud or being transformed into the cloud solutions. This model allows addressing security and privacy concerns when, for example, business doesn't want developer organizations to have access to production environment or data. This is especially true when the dev organization is a third-party contractor, for example. Another set of things, for example, could be, business drivers to pursue this model, this organization model, is that, there is a big suite of applications on the table, and there should be support teams, and the support schedule requires to span time zones. Customer communication should happen, and so on. In these cases, we should have a separate operations organization that will, kind of handle this type of load. And I would say that there are not that many developers I know who would want to take calls in the middle of the Friday night. Typically, in this kind of organizations, these two type of teams, or these two sets of teams, play, let's say, level 2 and level 3 support roles in the old ITSM terms. But all of this, compared to the previous model, of course, it covers the organizational needs. But on the other hand, this produces or introduces a lot of problems, and the amount and the size of these problems depend on the size of the organization. So what I want to say at the end of the slide is that both organizational structures work. But the previous organizational structure is more targeted at modern, new environments or new modern applications. And this model is more kind of works with more mature and the older organizations and or companies and older applications that are coming from on-prem to the cloud. So most of the time when we start working with some companies, we kind of trying to assess their organization models. And what we see is that most of the organizations that are coming now, at least as I see it, are based on the second organizational model, where they have separate clusters or separate organizations of people. Some of them are targeted at or can be named developers, and some of them like in a separate ops organization. So, and what's the problem with this? What are the problems that we can generalize and see with these models? The first problem I can name is an ownership boundary. So what it is, the ownership boundary means that, or basically without a clear ownership, it's hard to say who does what. And the main thing there is like, who is responsible for what? It's hard to give an answer to this question. For example, automation that delivers our code. Depending on the environment, it may work differently for various good reasons sometimes. Both organizations, ops and dev organizations, may change automation for their own needs and based on their own requirements. And then it breaks apart the body, the very body of the automation. And as a result, we may have two, or in worst cases, even more sets of automation instead of one. In simple words, we could end up having multiple pipelines for the same thing. This makes it much harder to build consistent pipelines and deliver our software in some kind of uninterrupted way. Another example is infrastructure ownership, especially ownership of the shared infrastructure. If there is a piece of infrastructure shared between dev teams on the dev side of the story, no one of them wants to claim, no one of them wants to claim the responsibility and take the responsibility for that shared piece. Additionally, all of these shared pieces can be visible to delivery teams in their own environments, in the lower environments, but production environment may be hidden from them, as I said, for different security reasons maybe. And there is additional party in that space, the ops team, which also, for their own reasons, changes their part of the picture. And this typically leads to automation to stop working at unpredictable points in time. So, because like all these parties, like dev organization and ops organizations, think that only their reasons are good enough to apply such changes. The next example, or the next type of boundary, or the next type of problem, is knowledge boundary, which is the most tricky one and the hardest one to overcome. So the more dev teams we have, the more products they make, the bigger the bigger the volume of knowledge that needs to be mastered by operations to successfully deliver and support the target set of products. If these products are integrated together in some custom way, which typically happens with the products that are just being migrated or being refactored to the, to be able to run in the cloud. So if these products are integrated in some custom way, the body of knowledge that, grows even faster and becomes even bigger. And operations team not only need to know each of these products, but also they need to understand the ways each of these products integrates to other pieces of the picture. If we imagine a graph of different products, we can say that, first of all, the operations team must master the nodes of the graph. But in case the communications between different components are messy, they also need to understand each of the links between, or each of the edges between all of these nodes. And in case these edges are unique, it just, in some cases doubles the amount of different pieces of knowledge that the operations team needs to master. So another point of this is that if automation for each of these products is unique to itself and produced by different by different dev teams, for example, and if this automation works differently between lower and higher environments, it also adds to the complexity. And if these pieces of automation, as I said, managed and produced by different teams, the overall picture, overall graph of these communications and different pieces, including automation piece, it becomes a mess. All of this, all the stuff that I just said, describes a knowledge boundary, which at first locks essential pieces of knowledge within each dev team, and second, even if this knowledge is released to operations side of the organization or of the process, it makes impossible for operations team to keep up with this volume of knowledge that describes all of these different pieces. And if the pace of change is very high, it's just completely impossible for operations team to master all of these things. The clear indicator of this happening with you in your organization is first when ops teams are, an ops team or your ops team starts saying things like, give us a simple step-by-step guide that always works. But at the same time, they say, if your guide is failing, we won't be able to troubleshoot it and we'll call you back even in the middle of the night. On the other side, at the same time, delivery teams and dev teams are complaining about ops not being able to read or understand their documentation. So if you see these two pieces when you work with different teams, this is a clear indicator that there is a knowledge boundary and people are not able to consume all the necessary technological detail that they're being thrown in. The bottom line here is that dev teams may produce documentation, bad or good, all the necessary details, supply all the necessary details to the operations teams. But the operations organization simply doesn't have enough time and capacity to study and understand all of these things. And the last but not least is the security boundary. So, as I said on one of the previous slides, in some businesses, security rules require that dev has no access to production. And again, this could be for very good business reasons. For example, if a delivery organization or DevOps dev organization is kind of a third-party contractors, or there are other various good business reasons for that, and this cannot change. So this adds a security boundary, and also adds to the to complexity. Firstly, how it works is that security elements like passwords, keys, accounts, certificates, and so on should be different. Obviously, should be different between production and non-production environment, which makes all the automation that we do pretty complicated because it requires proper secret management solution in that case. And there are not that many of them out there on the market, and the good ones are pretty expensive. So if there is no such solution in place, then Ops team starts to track all of these sensitive elements almost manually. And in conjunction with the knowledge gap or the knowledge boundary that I described just a minute ago, this creates a lot of problems on the security level, because we start seeing things like commonly used passwords or well-known passwords that are shared across teams or across products or across pieces of infrastructure. We start seeing self-signed certificates, expired certificates, missing updates, and so on. And all this becomes even worse when an operations team on its side misses some piece of knowledge that either was not passed to them or was not understood by them, and this makes this problem even bigger. So what's the solution for this, and what can be done in order to solve all of these problems? So the idea here is that to let teams focus only on their things. So let them minimize or shrink the number of things that they need to manipulate in their minds, and not to overflow other teams with the necessary details. This lets us basically break the knowledge gap, or reduce the knowledge gap, because not everything needs to be thrown out of your team. You just focus on your own things and let the system kind of hide everything else from you, and at the same time hide some internals of your product from other teams. And this is what OAM model or open application model does. Basically, just a few words about it. Like a year ago, on the last Ignite last year, Microsoft introduced this model as a solution for this kind of problem. This model is just, if you go to the GitHub and search for it, you will be able to find a repository. And basically what this specification is just a description of rules and data structures that you can use to build your own deployment system, so to speak. And this model allows us to kind of abstract certain pieces of the puzzle and let different teams focus only on their things without having to dive deep into, other pieces of the picture. So how do they do that? First of all, they introduce a certain set of roles. First role is obviously a developer role, right? This is like a developer role which is responsible for their code. They don't need to be responsible for anything else. So developers deliver business value in the form of their code. While they should understand the operational characteristics of their code they deliver, they are mostly unconcerned with how operational requirements are fulfilled. For instance, a developer may be aware that their code writes data to some specific path on the file system, but need not they don't need to think or concern themselves with what kind of volume or disk is mounted to that path, or what kind of storage is mounted to that path, and how these things are happening. On the other hand, there is an application operator role, which basically delivers its business value by configuring, installing, and managing the components that application developers supply. So unlike developers, operators are concerned with how these components are delivered and how their operational requirements are fulfilled. For instance, if developer has declared that some particular component writes data to a specific path of the file system, an operator concern themselves with mounting the proper volume to that path. And the last but not least is the operational people or infrastructure operators. They deliver their value by building the platform. So these are, purely infrastructure related role. And on premises, they can manage networks, physical hardware, servers, and so on and so forth. And in the public cloud, for example, they can manage cloud services. And if you think that cloud services needs not to be managed, that's a little bit of a mistake, I should say, because the bigger organization becomes, the more costs are required to run all of these things. So there should be a person who can manage and control what exactly is happening. And the same, on the other hand, there are some management tasks to control security landscape of the whole organization and so on. So these tasks are a little bit different from managing on-premises hardware, but there are still work to do on that field anyway, whatever it is, it's on-premises or cloud things. So these guys, or this role is to be played by people who manage underlying infrastructure. For example, infrastructure operators may manage underlying storage that creates all of these volumes and maintains all of these volumes which are then used by application operators to supply them to applications, to code. And in addition to these roles, the model also adds a set of abstractions, and these are key pieces to the picture. These abstractions are high level enough to be able to hide infrastructure level primitives and define applications in their own terms. The model defines, first of all, the model introduces a notion of an application that consists of, and each of these applications consists of components. So these are terms that are used within this open application model. So there is an application and there are components that each of these applications consists of. So these applications and the components are infrastructure independent, or, I mean, like, to the matter they could be infrastructure independent. And in simple words, you want to define your applications and supply parameters to your applications, but at the same time, you don't want to think about what's infrastructure lies, underneath your application. So you want to be able to abstract yourself as a developer. You want to be able to abstract yourself from application and make it so that when the application is deployed, or when you work with the system, with this deployment system, that's based on the idea of this model. When you work with it, you want to operate directly applications without having to know, or without having to manage underlying components or underlying, I would say, infrastructure pieces or cloud resources. So your element that you operate with is an application as a whole. So what we, in our project, we're faced with most of these issues that I just talked about. And in order to overcome these issues without changing the organizational structure. So all of these issues can be fixed in one of two ways in general, right? First way is to switch the organizational structure. So it basically merges these two different organizations into, together. So there is no knowledge gap, there is no the ownership gap, and so on. But this is like an organizational change, and for many business reasons, this cannot happen. On the other hand, all these issues can be solved by technological means without having to change the organizational structure. And in our case, it's impossible to change it. So we kind of derived some ideas from OAM, from the open application model, and we created a tool set that we call Genome. It's just a name that we gave it. So in addition to that, we extended the OAM model with our own concepts, because these concepts are required for us, or were required for us, and they're still required. And the fact that we managed to do it proves that the model itself, the OAM model, is very flexible concept, and it can be extended to your needs, and can adopt to any organizational structure. And in addition to that, I wanted to say that this model, the model itself, the OAM model, can be not only extended, but it can be extended within their own concepts and terms. So you can create new concepts. For example, we created an environment concept which didn't exist in the model, but this concept can be described using the abstractions that already exist in the model itself. So the separation of concerns between dev and ops organizations is being achieved by separating application definitions and environment definitions into different scopes. So basically, in this model, applications are described by something we call application application configuration document. So if we look at this picture, we can see that there are different sets of abstract documents that are used to describe applications, environments, and some other concepts. So what we say is that we have an abstract and at the same time unified language to describe an application, and on one hand, and to describe the target environments on another hand. So application configuration files are used to describe applications, environment definitions are used to describe environments. So the separation of concern on this level means that application configurations are 100% targeted at development team. So they prepare their definitions of their applications because they know what they do. On the other hand, environment definitions are defined and created by operations team because they are responsible for underlying infrastructure. And this means that application knowledge, or the knowledge that you need to have in order to configure an application, is still sits within the development team because they make this application, they know what to do with it, they know what parameters should be and so on. But the environment is separated and they don't need to know exactly where it is, how it's structured, what are the names of these resources, resource IDs and whatever. They just need to supply their application config, and then all these files are being passed through the PowerShell module that we create or that we develop to the engine that consumes these definitions and does its magic by merging these two pieces of knowledge together, like application related knowledge and infrastructure related knowledge. The last piece to the picture is this deployment database. So initially it was called CMDB, but then we changed the name. The role of this component is to keep track of all the logical elements that are being passed through this deployment system. It basically keeps track of all applications that are being deployed, all components, environment, secrets, parameters, relationships between all of these elements. So the deployment DB knows about what's there, what have been deployed, where it's running, which resources it consumes, and so on and so forth. Additionally, all these logical elements, high-level logical elements like applications are connected to the lower-level information coming from cloud. So we do not store any information or any details about the configuration of the cloud side of things, but we just link them, right? So the deployment database that we run and the cloud platform per se create the kind of the big configuration management database that we can use to know where each piece is running and what it contains or what it consists of. So the general idea behind all of this is that to make it possible to say that applications are managed by delivery teams and environments are managed by operations team, and then all these things can be operated right at that level. So if you want to deploy an application, you operate with the application as with the with a solid thing, with the whole thing. So application is a first-class citizen. It doesn't need to know about underlying resources. It's just a whole block of thing or the whole block, the whole piece that you operate with, and the environments are the different side, another, or other side of the coin. So you operate with environments as a whole without having to break it down into smaller pieces. So if we look at these things closer, these are the few examples that I can show, right? So if we look at the application configuration, on one hand, it's just a YAML file that describes the whole idea. So we say we have an application as a whole. It contains or consists of components, which has each of these has its name. There are parameters to each of these components, and these components are basically pieces of the whole application. So for example, in this case, it's just like a web app and the database. So delivery team or development team supplies this definition to the deployment system, and then deployment system does all the stuff that's needed, that's needed to deploy this thing. So there is no any information about underlying infrastructure, environment name, and environment type. These are only two elements that can this definition to the underlying infrastructure. Everything else is abstracted, so you don't need to know about all of these things. And this allows us to switch applications from environment to environment by just changing these two fields. Additionally, this file is basically, has a standard structure, which is easy to understand. It has few, high level or top level fields or top level sections and so on. And in addition to that, parameters are visible to operations. So previously they were stretched across multiple systems. Some of the parameters were stored in one place, some in another place, and it was hard to understand where are these pieces. And currently what we are targeting is that we are trying to say, okay, if you want to see the configuration of your application with all the parameters that have been supplied to it, even though they were tokenized or something, you can always pull the document from the database and see what exactly is there. Another side of the story is the environment configuration. An environment configuration is basically a similar file that at the top level is structured similarly to applications, but its goal is to define environment. And here we have, the environment consists of scopes, and each scope is basically a resource or set of resources with its own configuration, where the operations team is able to say, okay, we want to build a standard environment that consists or contains all of these resources, and the resources and these resources are managed by us, and you don't need to care about these things in your application configuration files. So let me quickly try to give you a short demo of how it looks like. Let me see if I can do it. Yes, I think should be fine. So I'm running this in a Jupyter notebook, which basically has some PowerShell modules loaded into it. So it's like it helps to document and run all of these things just quickly without having to memorize all the commands. And I have loaded everything and connected this thing to all the stuff that's needed. But basically, the first thing that helps to simplify management is that we can always look inside the module, the tool set that we supply, and see which commands are there. So each command has and associated help. So you don't need to, search for documentation anywhere. You can just, it's basically a self-documenting thing, right? You just import the module, and you're immediately see what you can do, and read through documentation if you don't know something, and find the examples. Another thing is, this is to connect to environment, and a few other things that I wanted to show quickly is that, for example, and this is like this, all this information comes from the CMDB that we have, right? With this deployment DP. So if we want to see, for example, which environments are there, we can always do it by running a command, and you can get the real-time live information about what's there, who created, if we dig into each of these objects, we'll be able to find the structure of each of these environments, which resources are there, what are the names of these resources, and so on and so forth. And this also helps us to build reports on the environment and application level to show the costs of each of these things and map these costs to their owners. So, and as I said, there are two major concepts that we operate with. It's just environments and applications. No details about resources. Well, there are details there inside of these objects, but on the high level, you don't need to deal with those things directly. So once we have these environments, we can, for example, look at the applications. I'm hiding the applications names because this is like, it's not a live environment, but still, just to avoid unnecessary questions. But what we can do is we can run this thing and see if it works. Yeah, we can see, that there are different applications within the different stages that are deployed into the system. And that basically allows us to, pull the application list that's deployed, see which resources are used by each of these applications, who is the owner of each application, and so on and so forth. And if, for example, we want to look at the particular environment and see what's inside of that, well, in this environment, basically in this environment, most of the applications are sitting in the same environment, but so these lists will be identical, but still, so you just supply the environment name, pull the applications from it, and so on. So basically, an environment in this terminology is the container of applications. And the last but not least is a possibility to look inside the application and see, the configuration of it. So if we run this, I think we'll be able to see, the whole thing, the configuration, the name of the application, how it was deployed, what the parameters were passed, and so on and so forth. Who is the owner of this thing, for example, which environment this application is, and so on. Unfortunately, I cannot show the deployment process. I don't have the configuration files for that. So what are the summary and what are the takeaways that we've got from this thing, from this experience? First of all, we have built our own deployment system, and this deployment system basically adds a layer of abstraction on top of the common things. And I think that the time has come not only to use existing deployment systems, but even start building our own system that can add this layer of abstraction. We want dev teams and operation teams to break this gap. We want them to be able to operate not on the resource level, but bring it higher. Say that the first-class citizens for all of these things are applications and environments, but not the individual elements of the cloud, if we're talking about the cloud. And on the other hand, we want to be able to not only deploy these things, but also see them and operate with them using, whatever people call CRUD operations, right? So you can kind of create applications, update applications, delete applications, which basically simplifies the process. Of course, there's some development needs to be done in order to do that, but it helps with understanding the whole landscape that you have. Another thing to the picture is this configuration management database. So you may think that that's like the old ITSM stuff that we don't need, that's the old thing, and we don't need to deal with ITSM. But the problem is that the bigger the infrastructure becomes, the harder it is to manage. And the bigger system is, it's harder to manage. So the database, this kind of database is a must. And we have to, and we use it to build a fully automated system that takes or makes decisions based on the infrastructure, or based on the information that is stored inside that system. And the last but not least is a tool set. The tool set uses this CMDB thing to understand all these high-level abstractions like applications, environments, and so on, and operate with them like directly, with on the level of applications and environments. So it's probably, so the outcome of this, like, it's that probably a time to start moving to the higher abstraction layers and potentially building our own tool sets and our kind of own deployment systems to fulfill this. So that's probably all I wanted to say. Any questions? I didn't pay attention to chat, so maybe.
I'm not sure that we have a lot of questions, Andrei. Like, it's your topic, not so easier to understand from the first time, I think so. But anyway, just I try to listen to you also and try to understand what's exactly it means for me. For example, as I don't know, like system engineer or DevOps engineer, it doesn't matter how to call it. My question will be, sometimes when you're working with abstraction and I see the problem that you working with currently, like nowadays, yeah, we almost all of us working with YAML, yeah, and nobody understands what's exactly under the hood, how it works, yeah. And if you create one more additional abstraction layer, do you think it can be just like bring us to the situation when you make some magic and this magic doesn't work and nobody know how to fix it? I mean, like every time when you add additional layer of abstraction, it's add additional, like level of magic. You create some lines of your YAML file, your declarative way, yeah, and it's working. But if something went wrong, nobody knows how to fix it.
Yes, so that's correct, I think. But, and that's another part of the story. So, of course, on one hand, you simplify life for operations and delivery teams, and with this simplicity, they can move faster because they don't need to deal with lower level concepts. But as you correctly saying, it adds kind of some misunderstanding. It can add some misunderstanding or problems with troubleshooting. But in our case, we have this team that builds this tool set. So their responsibility is to address this kind of things, I believe. So it's just, so what happens when this concept is introduced? All these teams become kind of development teams in a certain situation. So development teams develop the software that brings this business value, and the team that built all of these tools, they don't really responsible for deployments, but at the same time they are also developers, so they can talk the same language to the development teams and can understand what's wrong and troubleshoot all of these things and help them to make sure that everything works. And on the other hand, the tool set that they supply to operations team is aimed at simplification of the operations life. So they don't need to understand all of the application details, but they can operate applications relatively easily. So this team that builds the tool set is just a combination of developers and operations people who can talk both to both sides of organization. But at the same time, they are not in between. They're just supplying a tool set. So yes, that could be a problem, but in this kind of organizational structure, it looks like there are no other ways to achieve our goal, in my opinion.
Okay, I got it. We have one question. Does OM works with CNAP? If I'm right, understand CNAP is Cloud Native Application Bundle. I'm not sure that you're familiar with it, but anyway.
No, so the OAM, as I mentioned, is just a concept. It's not the software that's implemented. It's let's say it's a data model and a set of concepts that you can implement yourself or adopt. And as far as I know, Microsoft is working on implementation that brings this model into Kubernetes world. But as far as we are not using Kubernetes per se, we just implemented it for our needs on our own. And there are a whole bunch of teams out there that might not use Kubernetes for a set of very good reasons. So if you want to...
Sorry, Andrei, maybe it's the last question and we will finish. Is it a real production example?
Yes.
It seems like on your own current project, am I right?
Yes.
I see. And maybe the super latest question from Alexander, is it any information about how long it takes to team, like dev team, to start work with this model? Time to train, I think so. Time to understand, time to cover this. So from your perspective, like
from my experience, if everything works smooth, it's about a week or two for cloud ready application to be onboarded into this kind of thing.
2 weeks and we can start to work with OAM.
Yes.
Seems like not
so. I mean, like for delivery team, for development team that uses this tool, right? The development of this tool is a little bit trickier, but
I see. Okay, Andrei, you have to select the best questions. What do you think? Who will be a winner? What's the best question from your perspective?
Interesting. I was not prepared for this.
Okay.
So,
Anyway, just like I will copy and share with you all the questions who ask, and we will select the winner.
okay.
We are running out of time. Guys, thank you very much that you are with us. Thank you that you just stay here. And a special thank you for you for very interesting and honestly, it's not so easy topic. And see you next time. Hello.
Thanks.
Sorry, and let's go to our ending of this conference. See you. Bye.